Welcome, everybody. We're super excited again today to have Abhishek Narain with us. And today's webinar is going to be on data integration in Azure. Abhishek has been collaborating with us at Data Platform Geeks for many years now. Abhishek works as a senior program manager on the ADF team, and we are very happy to have him today with this webinar. Before I hand over the stage to Abhishek, let's just quickly remind you about Data Platform Virtual Summit 2021, which is just round the corner. Yes, this is kind of the last week, so to say, if you wish to register for the training classes. Pre-cons are beginning next week, September 8 and 9, and we have 15 classes lined up for you. There are a few pre-cons and there are a few post-cons. Apart from the community experts, subject matter experts from the industry, we also have Microsoft product groups delivering training classes for you. So if you see, wide variety of subjects are being covered at DPS 2021, which includes AI, data platform on Azure. We have PowerShell, we have DAX, SQL Server performance tuning, developer stuff. I'm doing performance tuning stuff. We have Azure Data Pipeline implementation, Azure Data Factory, big data clusters, lot of classes. But because Abhishek is there with us today, let me focus on his class. Abhishek and his team, so Sunil, Abhishek, and Lind are going to do this 8-hour virtual class on data engineering best practices using Azure Data Factory. With this class, you get to attend live and you also get the recording. So that's the special thing with DPS. No other data conference gives you the class recording. So you get 12 months streaming access. You can watch as many times as you want over the next 12 months, apart from attending live, which is a great value. Also, take a note of this discount code called SAVE20. That's the discount code. And if you wish to book today, you can book and you can get $20 off if ADF is your interest. For us at DPS, content has always been the king. We have spent an immense amount of time curating the content that we present to you each year at DPS. So yes, we bring you freshly baked sessions, as we call it, and about 127 sessions are live. That includes breakout sessions, deep dive sessions, demo sessions, short drives. We have data and AI Gurukul also with live roundtables. We have women in technology panel. We have diversity, equity, and inclusion panel. A lot of stuff is happening at DPS 2021. Friends, take a note. DPS right now for the community is free. So for the regular conference, for the 3-day, rather 4-day event, if I may call it, because it's going to run round the clock, 24 hours non-stop, covering all time zones. For live attendance, it's free. You just can go to dataplatformvirtualsummit.com. The link is there in the chat window, and you can register for free. But for the training class, if you wish to book, use the discount code SAVE20. So log on and book your seat today. We're there over the internet on Twitter, on LinkedIn, Telegram, Facebook, YouTube. You can take a screenshot of this. I'm going to count 5 seconds. 5, 4, 3, 2, 1, go. And connect with us. With this, we have Abhishek with us. Abhishek, thank you so much for coming on board again. It's such an honor to host you once again with Data Platform Geeks webinar. Over to our rock star for the day.
Thanks, Amit. Thanks, everyone, for joining this session. So welcome to this session. Today, we're going to talk about data integration on Azure. And we have a deep dive training coming up in the pre-con, where we'll go deeper into the data integration on Azure. And we'll talk about some of the best practices which people should be aware of, especially when using Azure Data Factory and Synapse pipelines while doing the data integration on Azure. So I work as a senior program manager in the Azure Data Factory team. So I'm here to talk about all the best practices and data integration on Azure. So we know that we have around 50 minutes now to cover all those things. So we'll keep it short, and then we'll have a follow-up demos as well. And we'll spend the last 10 minutes answering any questions that you have. So we know from the context of data that the worldwide data is growing exponentially. Just to put some numbers, data integration market is huge, and this is a common problem that all data engineers face. So putting some numbers again in context, 80% of enterprise business operational leaders say data integration is critical to ongoing operations, and 67% rely on data integration to support analytics. So analytics and data integration are very much, integrated. And one thing which you need to understand is for any analytics that you do on Azure or on any cloud, you have to start with the data. The data in an ideal world can be created on the cloud itself. But what we see with customers is you need a decent integration solution to be able to get data from variety of sources, especially with big data, and the V for variety is pretty important. So data is there everywhere on social media, on n number of sources, and you should be able to integrate and collect all those data, cleanse it, prep it, and then be able to join, do the transformations. And so that is basically a day-to-day life data engineer. And we'll talk about that more in details. What are the tools to support that? And then 65% of organizations prefer cloud platforms, and that makes it really easy. And especially in the days gone by when you had used SSIS and had to set up something, you would probably require an IT guy in an enterprise to get started with it, and it could probably take days, 2 weeks to get started with the whole solution. Now, with the cloud platforms, you can get started with the PaaS application in just a few clicks, as long as you have Azure or a cloud subscription. So that's how easy things have become, and hence 65% of organizations prefer cloud platforms to kind of existing on-prem platforms. And what we see is a typical bottleneck when it comes to data integration is the ingestion. When we are talking about cloud scale, on the contrary, you don't want to be blocked by the data ingestion, because the cloud can process. You can have hundreds of cores processing your data. But if the ingestion is not scalable, it's of no use processing those data, because you don't have the prerequisite, which is the data on the cloud. And hence, Data Factory comes in, which basically is the tool to kind of ingest GBs per seconds data onto the cloud, onto Azure. And it could be directly into the data warehouse, which is Azure Synapse Analytics, or it could be into a data lake based on the architecture patterns that customers follow. And then here's a bunch of customer momentum. We have some large customers using Data Factory. These are some numbers which I'll just point in time. What I want to talk about from Data Factory perspective, and again, the word when I use Azure Data Factory, I will be interchangeably using this word with Synapse pipelines. So if you're not aware, Azure Synapse Analytics is the solution on Azure, which is the data analytics solution on Azure. It basically is kind of a one-stop shop where you can go for doing analytics on Azure. And Data Factory is part of that Synapse Analytics, and it's called as Synapse Pipelines. So whenever I use the word Azure Data Factory or Synapse Pipelines, in terms of the functionality, in terms of the best practices, in terms of all these things that you learn, is consistent across both Azure Data Factory standalone and Synapse Analytics, the Synapse Pipelines component of that. So these are top 4 components of Azure Data Factory / Synapse Pipelines, it's extremely easy to use. We'll see it in the demos. It offers you both code-based and code-free ETL, ELT, which means you can choose if you want to write some Spark scripts, or do you want to run some Spark code on Databricks, or do you want to simply call certain Azure functions and run your Python and .NET code, or you want to use a code-free interface of Power Query, or you want to do a data flows. And we will go through the demos and see how easy it is to build data flows. We'll actually probably do a real world data engineering use case as well to understand that part, how simple it is. Now, the other part is you can rehost SSIS in just a few clicks, which is a win-win for any customer who has had SSIS. SSIS has been SSIS stands for SQL Server Integration Services. And if you have been using that, because that has been the ETL tool for ages now, the reason why we are talking about data factory versus SSIS is we know that SSIS is an amazing tool and it can do all your ETL jobs, but we also need to understand the limitations of SSIS, which basically is it doesn't work in a distributed fashion. So when it comes to big data and TBs and petabytes of data, SSIS might be a bit overwhelming. I mean, the data might be a bit overwhelming for SSIS in that particular case. But in case if you have a data or your data requirements are well met within SSIS, you can absolutely rehost the SSIS packages on Azure Data Factory and in just a few clicks without doing any changes. That's one of the easiest thing to get started with. And the benefit you get is you offload all the infrastructure management of SSIS, the cost that you're paying, turn your capex into opex and be profitable. So that's the benefit you get. And then you get built-in Git and CI/CD. The other pillar is cost effectiveness. So whenever I talk to customers, do understand that one of the key value props is basically the cost effectiveness of Data Factory, because it's a serverless cloud-based PaaS service. So you only pay for the amount that you actually use. So it actually is pay as you go. And if your load is less, or if you're running only one pipeline in a month, you only want to pay a few cents or maybe $1 a month, nothing more than that. So there is nothing that you actually pay as a reserve cost or license cost or subscription cost, nothing as such. Basically, whatever you use it for, whenever you use it for, you get billed for that, just like how you would expect a PaaS service on the cloud. And it's fully managed, it's serverless, scales on demand based on your volume, data volume. You can even specify units, so you can leave it on us to use or assume some default values based on your data. And then in terms of power, it gives you, I'm sorry, that's not updated, but it's 100 plus connectors. We just released the 100th connector last week. So it gives you 100 built-in connectors, and you can orchestrate and monitor at scale. So it's basically an orchestration tool as well. It's ETL plus orchestration tool where it can orchestrate your ETL packages, either when you write a code-free ETL or when you write a code-based ETL. It can do both of them. And then it uses a lot of intelligence that we have added in terms of understanding your schema. We know that sometimes you work with complex data types, and it can be not so simple, especially if you're not new to understanding how schema work and how schema drifts and how schema changes. What happens when that happens? And even performance tuning for that, say. So it is not a simple thing to do, especially when you're talking about petabyte size data. What is the best way in terms to get the better performance? For example, with data flows, you can do distributed compute, which means you can use partition keys. You can use all those partitions to dynamically or to scale up your compute needs. For example, you can in parallel start to compute using partitions. And sometimes it can be overwhelming to understand what kind of things should I be using to get better performance. And this is where the AI-based intent comes in, both in copy and data flows, which can help you select some of these settings and configurations without having to make a mistake there. And moving further, at a high level, Azure Data Factory overview, and it's going to be consistent across Synapse pipelines as well when you're looking into building pipelines using Synapse. So typical audience are data engineers, as we know. There are data scientists and citizen integrators as well. By the word citizen integrators, we mean people who have the need for data engineering, though they are not really skilled in a particular tool for data engineering. And data science use cases are pretty common. You have to get and prep the data before you can actually do machine learning trainings and stuff. And data engineers, we know majority of our customers are data engineers who are integrating data from different sources, massaging that data, cleaning it up, preparing it for the next step, maybe for use by data scientists or by business analysts. But in typical citizen integrators, what I mean is there are a lot of business analysts using this tool as well. Now, what are those data sources? Typically, the journey starts on-prem, where you have SQL Server or Oracle, or even file systems, CSV files there sitting up there. And then we do see there are a lot of customers with multi-cloud data, and that's a fair thing to have because you want to have your investments across clouds at times, or sometimes due to partners working with so many different customers, and the different customers having different cloud solutions and the databases and data warehouses across different clouds. There needs to be a mechanism how you could integrate those data coming from Amazon, from Google Cloud, onto Azure as well. And so we have those connectors for you. And then typically all the SaaS applications like Salesforce, Dynamics, 365, and all these applications would basically you would need to connect to those applications as well for the analytics, and hence we have those SaaS data connectors as well, and ingest it with 100 plus connectors, and then the next step starts is preparation, transformation, and prediction, enriching the data. And you have both options there, code free and code centric. And in terms of orchestration, we did talk about here, ADF takes care of orchestrating all your data pipelines and monitoring them. And similarly, there is a data lake, especially when you create a Synapse workspace, you get a data lake along with it. And it's also quite common architecture to stage the data, everything on data lake. So data lake is much less expensive than a data warehouse. And so you can maintain a data lake with all your data. You don't have to lose any of your data or clean up your data warehouse due to scale issues and stuff like that. And then start preparing the data in a ELT, extract the data and load it into a data lake, and then start transforming it when you need it, and then put it into a data warehouse for consumption through BI reports. And that is also one of the common patterns that we see. Power BI comes in for that. Now, talking about some customer scenarios. These are top 3 scenarios we heard. I want, for example, to unlock insights from all my data with analytics, and we'll go through each one of them. Second one is around SSIS, how to get started with that to realize cost savings. And the third one is I'm building a SaaS application and with optimal time to market. And time to market is very important. And so these are 3 use cases we'll talk about today. The first one is I want to unlock insights from all my data with analytics. And this is most common data engineering use case. And just using the same diagram that we used earlier, the options that the data engineer has here is, along with the 100 plus connectors to ingest data, you can use wrangling data flow, which is Power Query interface, especially if you come from Excel world or Power Query world, you would love the interface that wrangling data flow provides you, and you can easily get started learning, understanding your data shape, and then transforming that data. Or if you come from traditional ETL world and have used mappings in complete tools, you would find this familiar mapping data flows as well. And both are visual in nature. So one starts with more Excel or a tabular interface, and you focus on that data and then start writing transformations using Visual UI. The other one is where you start with mapping your source to a sink and adding transformations in between. So it's slightly a different interface, but whichever works better is what you can use. And then there are code-centric options like Databricks, HD Insight, Synapse Spark, Azure Machine Learning, where you can actually, which you can use for analytics as well. And then finally landing the data into the Synapse pool and visualizing it with Power BI. And so we did talk about wrangling data flows of the Power Query interface, and this is how the Power Query interface looks like. It's very familiar if you have used Power BI before, or if you have used Excel Power Query tools before, and you can use these interfaces within Data Factory, and you can wrangle through your data and define the transformations, remove columns, merge columns. All those transformations can be pretty much defined while you are actually visualizing and looking at the exact data in an Excel-like fashion. Now, the mapping data flow is slightly different, and some customers might prefer this. And you can start here with a particular source data. You in this particular model, you pretty much know what you want out of your data, what shape your final data should look like, and you start working towards it. From left to right fashion. So all the left side is your source data sets, and then you start adding transformations, and each of these steps basically generates some kind of a equivalent of a data frame, so you can actually validate each step, what data shape it looks like at that point in time, and based on that add another step. So you have lookups, you have the matching transforms, you have update transforms, you have alter rows, you have all the different kinds of transforms which we will see during the demo. And the benefit of both executions, and how it really differs from SSIS, is that both of these runtimes actually use Spark. So it gives you the cloud scale, as you may know that Spark is basically one of the most frequently used distributed compute platforms, especially for data analytics, and it can help you leverage multi-nodes and then perform all the executions that you're doing across those multi-nodes. And hence, it can give you that scale and the perf, especially when we're talking about using hundreds and thousands of nodes, and you can get like super performance right there. So this is the whole context that the data flows and the Power Query wrangling data flows, both of them use Spark under the hood, which gives you that performance, even if you were to just change the backend data from some GB source data set to a petabyte source data set. It can scale to thousands nodes to kind of give you the whole analytics pipeline, execute the same analytics pipeline in the same time or even faster. And these are some of those transformations which are code-centric: HD Insight, Databricks, Synapse Spark, functions, batch, all those things are available. And in terms of monitoring your data, it is extremely important when you're building complex data pipelines, data flows. You need to understand, how is my query runs optimal, or is there any scope of improvement that I can do? Because if it's KBs of data, really doesn't matter much. It's gonna probably you can improve it by a second or so. But when it comes to TBs of data or PBs of data, it can throw the whole data pipeline away because of latencies of hours, right? If it's not well performing, and hence monitoring, you should be able to see and understand each of those transform layers or steps that you're doing. What's the latencies that it shows up, and you understand the skewness, kurtosis, just to understand anything that you can improve. Is it just this particular data set run which is causing this problem, or is it a regular problem on a long-term basis? And you can understand all those values. Based on that, you can change your transformations, change your compute size, or optimize based on partitioning. You have a lot of those options that you can see based on the monitoring options that you get for data flows. You also have, for operationalized runs, you have all those options around restating the pipeline and activities, restarting the pipelines from point of failure. Again, a very common ask: what happens when my particular activity fails? Do I start from the beginning, or do I rerun it? Of course, there are certain best practices which we'll talk about in the tutorials, in the training, 8-hour training. We have a lot of time there to talk about certain data engineering best practices. So we'll skip those best practices in this particular session, but there are tons of best practices around how should you build a pipeline which can be restated in case if there are failures, and how do you go about that design? Now, these are some important things that you need to know, not while getting started, but especially when you are building pipelines for in production, to execute in production. You have to really consider, how can I make my pipelines rerunnable without affecting the data in my analytics store, right? It should not create double entries or dual entries when I do a rerun, right? So all those are certain considerations that we'll talk about in the training, and what are the best practices on building those pipelines which can be retried without actually affecting or generating more incorrect data sets in your final data store or data warehouse. Now, in terms of data factory, there are a few key terms that we will see, and we should get used to it before we get started. So things like you start with triggers. Trigger is basically when you kick off a particular data pipeline. And it can be done either on demand using REST APIs, or it could be scheduled based on a wall clock trigger, or it could be defined using a data window as well. It is also scheduled, but it is using tumbling window or a data window. And then many use cases actually use data windows. And the benefit you get there is it's very well slice driven. So you define time slices. And if something fails over time, or even when you want to do a back in time processing, again, it's a very common requirement, because when you build a data pipeline, at times, these are again common challenges that you have data sitting for the last 10 years. And so now, since you're adding a new analytics pipeline, which will analyze data which you weren't earlier analyzing in the last 10 years. And hence, you need to run some kind of a back in time analysis. Yes, you can always say, I can run a one-time trigger to offload, basically do the analysis over the last 10 years, but it's going to take ages, literally. And it's not scalable, right? Because if it fails in between, or it might be a 10-day worth pipeline, and if it fails in between, you're not going to retry it, right? And putting such kind of a condition on making sure you can rerun from the point of failure is going to be tough, especially when you're talking about last 10 years data. And hence, defining such data windows and running your queries based on those data windows or the timelines can really help partition your data pipelines in a much more scalable fashion, both in terms of performance and as well as in terms of recoverability, which is very, very important, especially when you're running back-in-time pipelines. And hence, data windows are very, very useful. I know it's, people feel when you start with it, oh, on demand sounds so cool. There's event triggers that sounds even cooler, right? So event trigger is basically something where you drop a file onto storage, and we can just start your data pipelines. You don't even have to have a trigger as such, a scheduled trigger or data window trigger. When the file arrives and you start your data pipeline. And this is also becoming very famous, which is event-based architecture. And that is coming in the data engineering world as well. And by the virtue that we work on a cloud service like Azure, we can very easily integrate with such events which are generated by database, which is like Gen2 data lake, Azure data lake, or even by Azure storage. And even better, we recently created event triggers or custom event triggers, which basically means that if you are using something like a event grid is something similar to a event hub, or basically a place where you can send events either through your applications or to your SaaS applications. And that can also be used as a trigger to trigger your data factory pipeline. So pipelines can be listening to your event grids. And whenever there's an event to execute your pipeline with certain values or message in it, you can basically parse that message as well as execute your pipelines accordingly. So you have a lot of scope of building dynamic pipelines and event-based pipelines and so on. But one of my favorites is data window, where you can define slices. It's a traditional data engineering approach. But yes, we have all those beautiful things, the event triggers as well. And then once the trigger starts the pipeline consists of multiple activities, one or more activities. And these activities could be, for example, execute data flow, the ones which you define, the transformations that you define, or it could be basically execute a copy job. There is a difference between a data flow and a copy job. Data flow they can actually transform your data. It runs on Spark, versus the copy job basically is where we expose all the 100 connectors that we're talking about. And so you can use that for bringing the data onto the Azure. And the copy job also executes on self-hosted integration runtime. So we have two primary runtimes for running all the data factory pipelines. One is the self-hosted. As the name says, you can host it on your premise, on your machine. And if you want to start today, you can set up a new data factory account, create a new self-hosted integration runtime, and install it on your machine. And you're ready to go. You can start integrating your data, connecting to your data through this integration runtime, which is self-hosted by you, and you can access your on-prem data. In a production world, of course, your IT team will operationalize that. But if you want to give it a try or do a POC, you can pretty much easily click on a self-hosted integration runtime, install it on your local machine, and during the demos, I'll show you how to set that up. It's just a few clicks. And then through this, you can set up pipelines which can read data from your on-prem sources, file share, Excel sheets that you have on your file system. You can basically quickly get started with data integration right there. And then we have the Azure integration runtime. The benefit of Azure integration runtime is it's managed, it's completely managed. And in the sense, the benefit that you get since it's managed is that you don't have to worry about the scale. You don't have to pay upfront for the cost. So there is no cost involved unless you're running a pipeline or an activity. You only pay for that duration. And that is a benefit. And of course, the scale factor, where if you need to have 100 nodes running, yes, we can have it ready for you in just a few or maybe less than a minute or so. And so that's the benefit that you get with Azure integration runtime. And yep, link services are basically connections to your data store. So it works here, and that's how the self-hosted integration runtimes using the link services are able to connect to your data stores. Now, the second use case is I want to migrate my SSIS to the cloud to realize cost savings. And this is also we hear very commonly from customers, and traditionally being using SSIS and modernizing or benefits of modernizing SSIS. So you get all the benefits around cost savings up to 88%. And it is fully compatible, of course, because it's the same runtime that runs locally is now running on the cloud. And it's extremely easy to use and experience. You can have the experience of the benefits of the cloud as well. And this is how it works. Basically, you lift and shift the package without no change in the package. And there is no migration literally here because you are running the same package onto the cloud. And it runs now in a fast fashion. Though you need to understand a bit of differences while rehosting this SSIS successfully, you certainly can now scale up the compute, which basically means that if you were earlier running the packages on a 4-node machine and facing some performance issues, now you can start to execute them on a 16-core machines or a 32-core machines or even a 128-core machine. What you do not get, or how it's slightly different or differs from Spark-based runtimes, is that your single package will always run on a single node. So even if you have 10 or 100 nodes, it'll always use one node. So it's more like scale up versus scale out, and it's basically doing a scale up in the sense you are scaling up the cores, but you are not really scaling out the same package on hundreds of nodes, right, in a distributed fashion. But we do understand that most of the customer scenarios using SSIS does not require that kind of a scale, and hence rehosting of SSIS is a very, very valuable proposal in terms of cost savings, in terms of even improving performance, of course, because if you were running on a 4-core versus 32-core on the cloud, you're certainly getting better performance onto the cloud. And it certainly helps you reduce your operational costs, streamline rehosting process, and operationalize your whole ETL with minimum amount of changes. And then you can enhance further your ETL packages with Data Factory. So this is how a Data Factory pipeline looks like. You can have multiple pipelines, and you can basically bring in SSIS package activity because SSIS by default does not have a trigger, and you can leverage all the modern triggers that Data Factory provides. For example, we talked about the event triggers, right? When the file arrives, why not just kick off the SSIS package executions right then? So now you can do that. That wasn't possible like an event-driven architecture when you were using SSIS on-prem, but now you can do that. You can achieve, or you can tie it with ADF trigger, which is the event trigger, even custom event triggers, whichever triggers you want to tie it up with, and then trigger this SSIS packages whenever the event happens. And so you can do that modernizing of your existing SSIS packages as well. And these are all the partners. And if you've been using SSIS, and you would have known these partners, they provide you with a lot of help with connectors, with integration toolkits, and so on. And all those are available on Azure Data Factory, within Azure Data Factory as well. You can use them with Azure Data Factory. And you can get benefits, 88% cloud savings with when you move to the cloud using Data Factory. And these are some certain customer changes. So we'll share the slides and don't have to really go through each one of them. And I want to build, the third one is I want to build the SaaS apps with optimal time to market. And timing is very important in any business, especially when you're using or building an analytics application or a SaaS application. So we have had some really large customers who are building analytics solutions onto the cloud. And the interface that they show up to their customers completely customized. It is their applications. For example, there are many marketing cloud solutions which uses this. And in those cases, it's the same building bricks, right? The serving layer changes a bit and it becomes an application, which you can actually host. And under the hood, the applications are sourcing data from the data warehouse or from Cosmos DB, wherever you actually push the data to, and showing it to the end users. And you can completely SaaSify the whole data integration process or analytics solution using Data Factory as well. So Data Factory can still act as a solution where you can use code or generate the pipelines using SDKs, REST APIs, and pretty much package it in a SaaS application. Milliman is one of those examples. ASOS is another example, and I will skip these. And Adobe is one of the largest. Their whole marketing cloud solution is powered by Data Factory. So we did talk about a bit things, and now let's jump into the demos. We talked about integration and in record time. That's certainly true with SSIS package executions. You can click and basically move your SSIS packages onto the cloud in just a few minutes. And you can construct your ETL in a code-centric or a code-free manner, and you can easily get insights out of it. You only pay for what you use. We talked about that. And it's powerful. It gives you 100+ connectors and orchestration capabilities in both Data Factory and Synapse pipelines. And you can leverage the Data Factory, it says that within Azure Synapse pipelines for limitless analytics. And what we didn't talk about today is some of the security functionalities. But again, that will be included in the best practices because without security, especially when you're talking about customers' data, PII data, data analytics is all around those data. And so security goes hand in hand. And hence, there are a bunch of security best practices, especially when you're dealing with a PaaS service or on a cloud. What are some good practices around security in terms of securing your data, securing in a sense, even thinking through how do you mitigate an issue if something wrong happens, right? These are some of the best practices we'll talk about in the training classes is what happens if your keys are compromised? How quickly can you, or what kind of loss do you incur in that particular case, right? So we can actually have solutions on Azure where if something happens, you can basically cut off access to all your pipelines. And all your pipelines will basically not be able to access in case if you find out there's an infiltrator or there's a issue within the team who's misusing the data, or if you want to set up some kind of an exfiltration setup to ensure only connections happens through whitelisted ports or IPs and things like that. All those things can be done. I mean, these things could be done on-prem as well. You could have used firewalls, you could have set different rules. Now, how do you reimagine that onto the cloud is some of those best practices which we'll talk about during the training. And we will see that this intelligence in the demo as well. These will be some of the security considerations and best practices. We'll talk about it later. We don't want to expand them. It can take us hours here. But these are some of the top of the mind things which you can use to make sure that your data pipelines are very well secured. You understand how the access control works within a single data factory instance versus how it works in the Synapse pipelines workspaces. Who can see your pipelines? Who can execute your pipelines? These are very important things to understand as well, because these are collaboration environments, especially Synapse pipelines, right? I mean, Synapse workspaces. You have multiple teams within your organizations, of course, but you can have more than one person using the Synapse workspace. And so you might want to set up certain access conditions and permissions over there. And then how do you manage the credentials? Because these credentials are not only the cloud credentials, these could be your on-prem data store credentials as well, your on-prem customer database, and so on. And how do you secure that? How do you encrypt using your own encryption keys, any metadata that is stored in ADF? So those are common questions and concerns customers have around the data in transit. How is it encrypted? Data at rest, how is it encrypted? What are the network security best practices? What should I use to secure my network, isolate my network, isolate my compute? And then Azure policy integrations. These are some bunch of things that we'll talk about during the best practices class. And I'm going to skip some of these details because it might not be something which you can cover in 1 hour. But before we get into the demo, I'll just quickly talking about the training class, data engineering best practices using Azure Data Factory. So my colleague, Linda and Sunil are going to join me and we'll run you through this 8 hours class, and we'll talk all these points that we talked about in a much more hands-on manner because those are all virtual classes. And we will spend about 8 hours talking those. Now, I'm going to quickly jump into some of the demos because you need to know what Data Factory is before you can get with these classes. And these classes are going to be advanced classes. So the whole purpose is to prep you up right now. So I'm going to quickly jump in and start sharing my desktop as well. So just give me a quick second. Okay. So now I should be sharing my desktop, the browser. And so what you see here is basically Synapse Analytics. And this is the point which I wanted to drive a bit of clarity on as well. Now, you can do the data engineering pipelines both in Data Factory and in Synapse Analytics. And we can actually see the benefits of using Synapse Analytics as well here. So what I'm going to do is show you some pipelines and build some interfaces. So this is how Synapse Analytics looks like. When you launch a new Synapse workspace, of course, you start from Azure portal, create a new Synapse Analytics workspace. You can create a new resource and select Synapse Analytics, and you can get started with that. So this is where you will come and you will see you can quickly get started with ingestion. I can ingest data, get started with that. You can visualize using Power BI. You can analyze using Spark as well. So you have a bunch of options here. Now, the place which we'll talk about from data engineering perspective is this integrate tab and the develop tab. So these two are the tabs. I'm going to expand that. This is the develop tab, and this is the integrate tab. This is where you build all your pipelines, and this is where you start with all your data flows right here, right? Now, I have some use case, and it's actually, let me just quickly get you what I'm saying. So this is actually not a bad, it's actually a pretty good use case. In this particular use case, what we are doing is we have data coming in from Zillow. Zillow is basically, think of it as it's a North American app which basically provides you can rent a house using Zillow, or you can purchase a house using Zillow. So it gives you good real estate data, right? And based on that data, you can take certain actions, or you can analyze that data, right? That could be a real world data engineering challenge. Now, what we will do in this particular example is we have the REST APIs where I'm consuming the data from, and this REST API is giving me a complex data, right? It's not just going to return me a key value pair all the time, right? REST APIs can return some complex data as well, and it can be convoluted, complex, data with child JSONs and structures as well. And this is exactly what it does. And if I were to visualize this data, I'm just going to go here and hit this, get the website where I'm getting this data from. Just to show you what this data looks like. And so this is how this data looks like. I know it's not a good thing to show you how complex this data looks like, but this is a real world data engineering challenge. I mean, this is how REST APIs throw data at you these days. All right. This is not like a beautiful table where you can simply select and map this source and map it to the sink and you're done. This is how you see the data today, coming from applications, coming from different SaaS applications. And if you were to even understand this JSON, there's starting with something called data table and array data, and it contains the different data points, right? And it looks like there's a date, looks like this is the value, dollar value. This looks like code. This looks like a area name or source name and things like that. And this looks like an array. So you have multiple such set of data, right? And seems like this API is queryable. So I can basically write a question mark and write some queries as well. We're not going to get into that, how REST API works. So leave it right there. But what I wanted to understand is looks like a complex data type, right? And how do I simply, if I were to parse this data and load some of these values, these are the 4 key columns, right? The source of data, the area code, the date, and the value. This is basically an average rental value. As I said, this app called Zillow is what you need when you move to the US and you're looking out for a rental house, and you want to figure out which is a good or a cost-effective area to stay in, or if you want to stay in a luxurious area, which is a more expensive area to stay in, you need this data. You can use Zillow app, or you can basically get this data and analyze this data. And so this is the data engineering challenge that we want to solve today. Now, let's see how we solve it in just a few clicks. So we set up a link service to the REST API. We put the path where the data is from, and we use a keybase dot. It's typed as an password. It's a free API. You guys can try it. Thanks to Gwendal, the website, which is giving us this data. And so once this data comes in, I'm just going to create a link service for REST API. And here's my base URL. Do a test connection just to validate it works. Yes, it works. I have saved it, so it doesn't let me save it again. I'm going to cancel the screen. Now I can start with my data flows. This is my data flow, and I put it as extract and load Zillow data. And here. So start with the first step, and you can easily add more steps based on your requirements. You can create a new branch of this, or you can do a join in case if you have another data. For example, I can give you probably an exercise, and these are the things which we'll do in workshop, that we will actually do exercises, and we'll give you certain tasks, and we'll do it all the time. I want to join this data. Let's first, get started with data, consuming this data. So this is my REST API, the data sets. There's something interesting called Workspace DB, which we'll talk about later. This is really something that you only get in Synapse Analytics and not in ADF. This is how the ADF pipelines would look like as well. I have other tabs. We'll get there. Everything remains the same skill set, same knowledge, same data flow, same UI, but you get additional Workspace DB, and we'll get to know what this is. Workspace DB is pretty interesting. Workspace DB is basically, think of it as a metastore based or a database or a data lake based tables, right? So what Synapse does is it has a meta store, and you can put all your tables, or you can also call it as Spark tables, right? So Spark table is nothing but, under the hood, a Parquet file sitting on a Gen 2 storage. And the benefit is that you don't have to really pay for like a expensive data warehouse, yet you can actually see data in a tabular fashion in the Workspace DB. So we will write it into a Workspace DB. It's going to be much more cost efficient, and it's going to be native to Synapse. So we can start analyzing the data right from it's landed there without having to worry about, oh, it's CSV, we have to read it in data frame and to do a lot of things. You don't have to worry about that at all. So we'll do that. After transforming it, we'll post it into a Workspace DB and analyze that data. Now, before we get there, let's start understanding what this data looks like in data flows. So we go to the projections, and projections already understands, once you import the schema, it tells you, oh, it looks like this data has, it's certainly a complex JSON. You put it, a format as JSON over here. You can do some settings here as well. And now what you can do is on this particular step, you can even have XML format in case if you have XML format. So we know that certain customers have data with different formats. So you can specify those data formats here. I know it's an array of documents because we analyze that data, right? It looks like it had array of values in it. And so select this option over here. And then I move into projection. It's a get API call that I'm doing. Go into projections, understand this data. Seems like body contains two different arrays, complex data types, which is data table, and something is metadata. Metadata is not necessarily for engineering purpose. It is basically for the connector purpose to understand, because REST APIs can return me data in a more scalable fashion, in a distributed fashion, right? Not every call will return me all the data, but it can only return certain batches of data. And hence there's a next cursor ID as a metadata, which our connectors can understand and make sure that even if your REST API is returning a billion rows, we can actually get those billion rows by actually traversing through the next cursor ID and requesting that data set. So that is by default, the connector gives you all those beautiful things. So you don't have to worry about, you can neglect the metadata part of your REST API body. Now, within this, I have certain columns and I have an array of data. So I have multiple rows of data, which equates to array here. And I can see the column. Column contains basically name and the type of columns, which is good. Now, if you do a data preview, each step gives you an option of doing a data preview. So this is basically completely visual. You don't have to write a single line of code. If you may want to write, you can write a query, but you don't need to. So here's what you see. And this shows up as these are complex types, of course, so we cannot just flatten it and show you here. So you can see that data types by clicking here, and you can see it has columns and it has data. It shows you array signs here. I can go inside that and click through and expand this to see how each row looks like. And each one inside this row contains what type of data it is. You can see it has array marked as 1, 2, 3, 4. You can expand each one of them and see the actual data in it. So you can see it's an array. 1.1 is basically this local name. Then 1.2 is basically this, and so on. So you can basically traverse through that. So this gives you a good understanding how you need to do the mapping. Now, at this point in time, I know it's so complex data type, and it's an array inside. It's kind of an object, and I need to parse through that. So I'm going to flatten this a bit. Rather than going inside data, inside each one of these items, I'm going to simply flatten it out so that I can get the data out. And this is what I do here in this step. It looks pretty complex, right? But it's actually very simple. Once you start with the flatten transform, you can flatten this and say, I want to flatten based on, this is how your body looked like, right? You had body, and then you had data table, and then you had columns. So I'm going to flatten based on two particular columns, right? One is columns, and the other one is data. Data was an array of multiple rows equivalent in it. And so I'm going to flatten it based and call it columns and data. Now let's have a quick look. When I do this with the previous incoming stream and I unroll it by data, how does my actual output look like? It's still going to be a bit convoluted. We'll get to solve that in the next step, but we are already in the process of making that data much more readable. So now you have two columns. One is columns and name of the columns, and then the other one is the actual data, right? So it's still in a better format than previously. We were able to get rid of that, and we were able to flatten the data, because now you can click on each one of them, and you don't have to click and click. You don't have to go inside it twice. You can start to see each one of them right now within a single row, right? It's actually not single row, but the data has been, you can say, flattened or unpivoted already one level now, and you can start to see all of them together, which is a great thing. Now go to the next step, which is I want to map each one of these data points, because it's actually part of the same value. This particular data 1, 2, 3, 4 equates to a common region, and the region code is 9999, right? So I should be able to basically map this to certain column names. And what is the column name for this? I can actually see it right here. So here's my column names, and each column has a name. It says it's called, it's a type text, but it's called indicator ID. Similarly, if I want to see the other columns, I can expand it. There's a region ID, the second one. The third one is date. And the fourth one is the actual value, the cost of it. And so the next step is where we derive these columns and we map it, each of these columns, region ID, date, value, to an expression. Expression is a way of specifying in data flows, saying, this is how the generic pattern looks like, and you can define the pattern using expressions. So we are saying that all the data array that you have, the first field of that maps to indicator ID, second field of that maps to region ID, and third field maps to date, and then fourth field maps to value, right? Or you can do value, cost, whatever you want. And one thing which I didn't show you in the beginning is option over here, which is projection up there. The sync. Oh, we'll achieve to the sync. So this is where we do the mapping, and this is at the point in time you can come and click on data preview to see all your mappings. And I know we are short in time, so I'm just gonna be a couple of more minutes with me, and then we'll just reach towards the end. And these are the 4 columns that now you're seeing. It's kind of flattened, and you can understand it better. You can grok it better. You can see those region IDs, date, and stuff. But I still see some interference. There are 2 arrays which I have to remove from my sources, right? And I'm going to do that right away when I do the mapping to the sync. So in this mapping, you can see we mapped it, and we basically removed the 2 columns over there, which helps us get a much more cleaner data. Now, when I click on refresh, you will see that those 2 columns are gone, and you have those 4 beautiful columns which you wanted. And this is how you actually ended up with. You started with a complex data type, which was a complex JSON, having multiple arrays and child structured in it, and you were able to flatten this out in just no time, just adding 4 clicks and adding a flattened transform and a derived transform. And the benefit now, the next step which I wanted to show you is this is the database sync, which basically means that I'm going to use a Workspace DB, and I'm going to use a workspace database. This is not a data warehouse, right? It's a workspace database. It's basically a Spark-based database. And I'm going to write something to that. You can edit and create tables. These are all my Spark tables. The beauty of the Spark tables is when you run this whole data flow transform, you can actually see all your data in this data tab. And these are all your databases. So you can see there is something called Fabrics. This is SQL, and this is SQL means it's a SQL pool. It's basically the data warehouse, right? But you can see the other database, which is the Spark one, right? And these are workspace database. This is what we mean by workspace database. And you can expand them. And since I have executed this data flow once, you will actually see a table here. And you will see all the columns of that table, which is nothing but what we actually created here, the mappings. And you can see the value. And you can easily, if you want to see or validate that, you can write a SQL script, right, to get the top 1,000 rows and execute that using a built-in SQL as well. Or you can even do is even execute a notebook against it. So you can do a data frame. This is the best part of Synapse Analytics, that you get best of both the worlds. You get you basically get Synapse. I think I will have to start the pool. but let's do that. It's going to take a couple of minutes, so I should have done that earlier. But this is basically an interface. Since we created a workspace database, it is not only accessible by SQL, but it is also accessible by Spark. So you can use Python or you can use Scala, and you can access the same data sets that you created. So it's a much integrated experiences. You bring in the data using your integration data sets, which we got through. This is slightly more complex. Maybe we were talking about this pipeline. And the way you got the data in here and put it in a workspace DB, and it generated a table called Zillow here because we called it Zillow. And you can basically create another one as well. So if you want to see a demonstration, a quick demonstration, I can call it, this is my DB. Oh, this is my database, default database, and I can call it Zillow 2 and simply hit on the debug to execute that. It was, I think, in integrate pipeline 5 and just putting a quick debug. Once it executes, and should execute really fast because my debug cluster is on, so it's going to take a few seconds, and it's going to execute the pipeline. And once the pipeline is executed, what it'll do is it'll create a new table. So I can generate a new table, I can insert, upsert, do all those operations in that table, and it need not be a data warehouse table. It can be a data warehouse table, or it can just be, you can see just 18 seconds it took to execute this whole Spark code, get the data, which is more than 100,000 rows, and then be able to transform that and create a table here. So I'm going to go back here, refresh this guy here. So you can see you have Zillow 2. And if you want to analyze this data, you can connect to Power BI. You can use this data sets directly to predict with the model, train a new model. So this is how integrated the Synapse workspace is. You can generate data sets. You can generate Spark data sets. You can generate, we call it workspace database. You can generate, Synapse data warehouse data sets, and quickly get started with machine learning or notebooks, right? Starting with a data frame, that's all. So it generates the code and you can just hit on this button and get started with. So this is how simple and easy it is. Let me quickly also see if I have my Spark pool up and ready, still getting ready. So once it's ready, I can execute this command and actually show you. Yeah, it's ready now. So I'm gonna do a data, let's do this. It's executing right now. And it should take just a few seconds, and it's doing a simple select star from Zillow, right? The table that we generated, and I'm going to do a df.show. Basically, it's going to show up the 1,000 rows, the first 1,000 rows in the data set, and right now it's executing that. So once it does, I'm just going to hit on run, and it's executing that job. You can see it uses 2 executors, 16 cores. I don't have to worry about that. It's all managed by Microsoft. So if tomorrow I need a bigger pool, I'll do that. And now you see, I'm able to validate that data using my Spark code. And this data was generated by data flows, right? And it was all done visually. I didn't need to write any codes at all, and nor do I need to write now, just using it for validating the data. But this is how easy it is to, reach from here. This is where data engineers start with, and this looks like crazy data. You cannot even write it onto a CSV. It's really crazy, and this is what we achieved in just a few clicks. Much cleaner, and we haven't yet gone to a state where we're using machine learning and doing some kind of an advanced analytics, creating new columns, joining this data, which we'll do during the training class. This is a starting point of it, and during the classes, this is what we want to do much more in detail. And thank you for that. And I know I've kind of I showed like 5 minutes extra. Sorry for that. Hope this was useful. We will continue with this during our training classes, and I'm going to quickly again share back my presentation wherever we were, and just to make sure if there are any questions, I'm right here to basically answer all your questions. And this is the class which I was talking about. We will basically continue from here in this particular class, where we will actually see more of such data engineering challenges. It's more of these sample data sets, complex data types, and how you get started. What are the best practices in terms of using data engineering pipelines and on the cloud. So that's all about which I wanted to present, and I'm happy to answer any of your questions that you have. So please feel free to post it in Q&A. If you have already done that, I'll be reviewing that right now. And thank you for joining today, the session, and hope to see you in the virtual training class, and have a great day ahead.
Thank you so much, Abhishek. Wonderful demo-packed session. There's one question that has come from YouTube, and I think it's a common question about people having issues, troubles migrating their SSIS packages to ADF.
Mhm.
So the question is more around what are the best practices to move SSIS packages to ADF? I mean, do we rewrite them completely, or are there tools to do that?
Yeah, that's a great question. There are tools that we offer, not really tools, but we offer things like SHIR proxy. The SHIR stands for self-hosted integration runtime proxy. Now, the common problem that customers face during migration is your data stores are on-prem, right? Most of the times, that's where you were using SSIS packages. And so when you start to move these packages onto the cloud, you don't have a line of sight to those data sets, right? Like your on-prem SQL server or on-prem Oracle server. Now, this is where most of the problem starts. 99% of the problems starts here. And so to solve those problems, we recently released a self-hosted IR proxy approach, which basically means that you can install the integration runtime on your on-prem. So that's the extra step that you need to do. But by the virtue of that, the SSIS integration runtime can access your on-premise data, the Oracle and the SQL server, through that hosted agent that you have. So you still don't have to do a code change here. You don't have to rewrite that package here. And you will be able to access your on-prem data stores from the SSIS packages running onto the cloud. That's one of the approaches. That's I would say, the simplest approach. You can still do a lift and shift without facing any problems. Better approaches are even when you do a network peering, when you do a site-to-site network peering. I know this is slightly advanced for a data engineer and even for me, but there is a mechanism where you can do a network peering from the cloud where your SSIS runtime happens, executes, and the on-prem network. And you have to do a both-way peering. So when you do it's like a VPN, basically, site-to-site VPN, or we also call it as express route, which is a dedicated network that network providers can offer you to set up from your on-prem network to the cloud. And all these things require a lot of time and setup requirements and stuff like that. And hence, I would say if you're an enterprise who already has an express route, this model will work very well as well, right? You don't need really a agent to access the data, because agent can always face a problem in terms of scale and stuff like that. Versus in this approach, you have less of a problem because you have a dedicated channel. So these are two common approaches that we see. We also see some customers remodifying that, and that is only required when you're changing not just your SSIS packages, but your data sources as well. For example, you choose to migrate the whole environment to the cloud, right? And you want to pacify the environment. Pass, you want to make it pass, right? And so when you do that, you, of course, are changing your data stores, the connection strings, and hence you will have to change your SSIS packages, right? That's not going to magically take care of migrating your packages. So this is kind of a third case where you are actually changing your data sources as well, or migrating your data stores from on-prem SQL Server to Azure SQL, or even IS hosted SQL or SQL MI. In all these cases, you will have to do a bit of a connection in your SSIS packages as well.
Well, with this, thank you so much, Abhishek. Thank you, everybody, for joining today's webinar. Hope this was worth your time. Goodbye and have a good day, rest of the day, whatever is ahead. Thank you. Thanks, Abhishek. Bye.
Thanks, everyone.